our question asks us, how many toothpicks will be needed to form the 50th? The 50th figure in this sequence. So let's look at this sequence. So the first figure in our sequence, they look like little houses. How many toothpicks are here? We have 1, 2, 3, 4, 5, 6 toothpicks. So our first object here, our first figure, has 6 toothpicks. How many do we have in our second figure? Well, we're going to have these 6 that we had in the first, right? This is the first figure right here. Let me just trace it. That's the first figure right there. And then how many new toothpicks are we going to have? We have 1, 2, 3, 4, 5. So we have 6 plus another 5. So we have the 6 in the original one plus another 5, which is equal to 11 toothpicks. Now what happens in this third object, or this third little toothpick house-looking drawing thing? So we have our figure from the two houses. So we have those right there. This is the exact same thing that we had as our second object. So that's that right there. And how many more do we have? Well, it's going to be the same thing. We've just added on this other extension to our house. You can view it that way. So we have 1, 2, 3, 4, 5. So it looks like every time we go down this sequence, or we add a new term to the sequence, or a new object to the sequence, we're adding 5 toothpicks. So here we're going to have 11 plus 5. There's 11 toothpicks in this part of it, and then we have another 5. 11 plus 5, which is 16. Same thing over here. We have 16 in this part of the drawing. That part of the drawing is going to be 16 toothpicks, if you draw all of that. And then we're going to have another 5 right here. So this is going to be 16 plus 5, or 21. So how can we figure out how many toothpicks we're going to have in the 50th figure? I mean, we could draw 50 of them, but it's going to take us forever. So all we have to do is realize the pattern. Every one, we're just going to add 5. Or we can even come up with a formula for the nth figure. How many toothpicks in the nth figure? So here, in the first figure, we have, you can view it this way. In this first figure, we have 1 plus 5 toothpicks, right? We have this 1. You can imagine that was always there, and then you added 5 right there. So that's our first term in our sequence. Our second term in our sequence, what do we have? We have 6, which is 1 plus 5. So we have that 1 plus 5, plus another 5, plus this 5 right here, plus another 5. And then our third term in our sequence, what do we have? We have all of this business that we had in the second term. So 1 plus 5 plus 5. And then we have another 5. We do it in green. We have another 5. And then finally, in this fourth term, what do we have? We have, so in the fourth one, we have everything that we had in the third figure. So 1 plus 5 plus 5 plus 5. And then we add another 5. We add a fourth 5. We add a fourth 5 right there. So why did I do it this way? Because I wrote this first one as 1 plus 5 instead of just a 6, because you can see, well, look, I had a 1, and then I had 1 5. Now I have a 1, and I have 2. I have 2 5s. Now I have a 1, and I have 3 5s. Now I have a 1, and I have 4 5s. So you might see the pattern. If I had the nth term, right here, I will have a 1 plus n 5s, right? The first term has 1 5. The second term has 2 5s. Third term has 3 5s. Fourth term has 4 5s. So the nth term, if this is, if this is 10, it's going to be 1 plus 10 5s. Or if it's n, if I'm kind of abstracting a little bit, I'm going to have 1 plus 1 plus 5 times n. Right? And try it out. If n is equal to 1, it's going to be 5 times 1. If n is equal to 2, it's going to be 5 times 2. If n is equal to 3, it's going to be 5 times 3. So that when the 50th term, if we're talking about the 50th term, how many toothpicks are we going to have? We're going to have 1 plus 5 times 50. Right? N is 50 here, which is equal to what? 5 times 50 is 250. That's 250. And then we add 1. We're going to have 251 toothpicks will be needed to form the 50th figure in this sequence.